So this is our boat trip project. Our group members are Nicholas Ayala, Matt Jers, and Robert Cruz. What is our project about? It's about material science behind shipbuilding and why concrete wasn't successful as a hull material for the SS Selma. Ships are meant to last a long time, decades or even centuries in the ocean. However, Selma was not able to. The chemical composition of the hull determines the ship's reliability throughout its lifespan. Since concrete isn't malleable like steel, it was unable to take the stresses and strains of the ocean. Duties and agreements of the group members. Three group members are Matt, Robert, and Nicholas. Team manager was Nick. Team facilitator was Robert. And the team manager and research facilitator was me, Matt. We faced a challenge of choosing which problem out of the three we had brainstormed which to solve. This was overcome through evaluating the relevance of each problem and how observable they were. The agreement mentions talking together so we could communicate and come to a consensus on our problems. Individual proposals included making engines more efficient, making engines simpler, and why concrete was not used for ships. We chose to focus on the material used in the SS Selma.
The SS Selma was a ship with a concrete hull finished in 1919. It was um, it was actually released on the same day the World War I ended. It was built in Alabama, Mobile, Alabama. It sustained structural damage only a year after it was built. It had a 60-foot crack on the hull, which made it no longer safe to operate. So it was towed to Galveston for repairs. Unfortunately, there was not many people who knew how to fix concrete ships. So they were unable to fix the ship and it had to be sunk only 2 years after it sustained its damage. So right here is a picture of Selma before it was sank. This right here is where the Selma sits now. Sits in Galveston Bay. It's been there since 1922. It's been there over 100 years. It's right next to Pelican Island. And this right here is the location of our picture, which you will see on the next slide. This right here is the SS Selma in person. This is what is left of it. It's all rusted, partially underwater. It doesn't work anymore because it was made of concrete. It sustained severe structural damage. These are the coordinates where you can find the ship if you want to go see it for yourself.
I'm here to talk about a little bit of the background of the SS Selma. The SS Selma was not the only ship to be made of concrete and was abandoned. It was actually a part of a series containing 12 different ships, as Bender 2024 had said. Concrete hulls are no longer a problem, as concrete is no longer used for making ship hulls. However, the risks it carried when it was used were a weak hull that could easily cause the ship to sink. Now we use steel, which is more durable and allows for ship hulls to be malleable and take impacts of the sea. As said here, material scientists exist for these encounters. Their job is to find a cost-effective material that has strength, malleability, and is lightweight. And an example of this is obviously steel. It can take hits and it's pretty lightweight. How engineering can be applied to this is engineers should be able to handle this problem by using a better material to build reliable hulls. Our idea to overcome this problem is to use steel. It is not too expensive to make and is durable, malleable, and rust resistant. As you can see from this chart, the steel of the steel stress is way better than the concrete stress. And for ships to be able to have this type of stress containment is really good because you don't know what you're going to encounter in the ocean. And if you take a hit with concrete coal, your ship's going down, as we saw with the SS Elma. And these are our references that we got for the slide.